What we have here is a time, speed, distance problem. What the question is asking is to estimate the time en route for a flight between two airports on the chart with a given wind and a given true airspeed, and then adding extra time for the climb out. We have the information that we need here in the question except for the distance and the direction of the flight. The distance and direction, or in other words, the course, we will have to compare with our winds to figure out how our ground speed is affected. Once we have our ground speed, we'll use that with the distance to calculate the time required. So the first thing we'll have to do is look at our chart and measure our distances. And looks like we're going from a flight from Area 4 from St. Mary's to Priest River Airport in Area 1. So what we'll need to do is draw a line. So we use our plotter tool to draw a line connecting 2 points. And the flight's going to be from St. Mary's to Priest River. Now we can see the true course here is 348, so we'll want to write that down. Now we need to measure the distance. Now the FAA charts are not printed to scale, so I'm actually going to hold a piece of paper up to the screen and make a mark. You see, and then I can hold the piece of paper up to the chart just to show you what I'm looking at here. Every minute of longitude is equivalent to 1 nautical mile on your chart. So to the larger marks, that's 10 miles. And from one latitude line to the next latitude line, that's 30 minutes of longitude, which is 30 nautical miles. You don't want to use the latitude lines because minutes of latitude get closer and closer the further you get to the North Pole. But all the longitude lines are the same length all the way around the Earth. So that's what we'll use. I'm going to call it 54 nautical miles. So I'll write that down. Back to our question again. The winds are from 300 at 14 knots. Well, winds aloft are always given to us in true degrees, so that's good. We won't have to convert the true course to magnetic as we measured it on the chart. So now let's mark our winds on our E6B. You want to turn the dial to the degrees where the winds are from, and then you'll slide the slider. You'll notice that each arc on your plotter is marked in 10-knot increments, with every small little mark representing 2 knots. Notice that these are all the same distance away, so it doesn't matter where we slide this to mark our winds. We just want to set the dot over one of these heavy lines and then mark our winds up from that. So our wind was 14 knots, so there's 10, and then 12, 14 knots, and we'll put a dot right there to represent the winds are 14 knots from 300 degrees. It may help to draw an arrow to just help visualize that this represents a wind vector. The next thing we're going to do is dial in our true course. So we'll dial 348 degrees here and see that our winds are a left headwind. Now, to determine what impact that headwind has on our ground speed, we'll place the wind dot over our true airspeed. So we'll need to slide 90 underneath our wind dot, or our wind vector, if you will, and find out that our ground speed is only going to be 80 knots, even though our airplane is traveling at 90 knots, we'll only be crossing the ground at 80 knots. So now that we know our ground speed and we measured our distance, we can calculate how much time is required. To do that, we'll use the other side of our E6B. And how this works is every E6B has a heavy arrow drawn at the number 6 or 60. We always set our rate at the large arrow on our flight computer. So we'll set our arrow at 80 knots. And we notice that time is indicated on the inner scale. These are increments of time, you see, whether it's 70 minutes or 7 minutes or 700 minutes. 70 minutes would also be an hour and 10 minutes. So time is always read on the inner scale, and distance is always read on the outer scale. So we'll look for 54. Here's 50. It's not 500 and it's not 5. It's 50. 4. And on the inner scale, we'll see that it would take not 4 minutes. That wouldn't make sense. Not 0.4, not 400, but it would take 41 minutes to fly 54 nautical miles. So 41 minutes is our total time, and the question said to add 3 minutes, so I'm coming up with 44 minutes total required as our answer. Closest to 43, and that is correct.